Measuring the properties of LNG to facilitate a fair and equitable trade in this increasingly important energy commodity. Orbital Global Solutions are proud to present advanced and proven know-how to ease the technological burden of this complex problem. Typically, the heating value and other properties of LNG are measured by gas chromatography to the well-known industry standards for natural gas. This requires a sample of the LNG, a mixture of cryogenically liquefied hydrocarbon gases, with vastly different boiling points to be vaporized without changing the relative concentration of the constituent components in the vaporization process. To stop component separation during vaporization in this type of fluid is practically impossible. There will always be a bias for the lower boiling component to preferentially vaporize, as shown here with the red molecules, methane eluding first. This has the tendency to make the vapor sample have perturbations or disorder in component concentrations compared to that in the liquid phase. Because chromatography uses a tiny part of the sample stream to make the analysis and measurement, this makes chromatography one of the worst possible methods of measurement that could be used for this application. Chromatography literally cuts a tiny slice of the sample from the sample path and injects it into the separation and counting stream. We therefore rely upon this tiny slice to be exactly the same as the entire sample stream. With the inconsistency that the vaporization process generates, we have already said there will be perturbations in component concentration. We take a great risk. Every time we make a cut, we have automatically assumed that the molecular concentration in that cut section is identical to the rest of the sample. Here you see an image of our measuring device, GasPT LNG, which is certified intrinsically safe for use in Zone 0 hazardous areas, and through which we pass and continuously measure the entire sample, not just a slice of the sample. By using a device that continuously measures all the molecules in the sample path, then perturbations are no longer of great concern, as we can and are able to reliably average out any inconsistencies on a very short and optimum time period, thereby producing a measurement in a more dependable way. Further within the apparatus, GasPT LNG, the primary measurement device, the spherical resonance chamber, obliges a mingling of the molecules entering it to ensure an even more reliable measurement.